Welcome, students. Today we're going to look at reading graphs of functions. Before, we were given an equation for a function, and we used that to figure out what the graph would look like. Today we're going to go kind of in the opposite direction. We're going to be given the graph of a function, and we're going to use it to find out numerical information about that function. We're going to be using graphs of functions that we made in the previous lessons, so you'll want to get your notebook out and look at those graphs so that you can reference them. You might even want to make copies of those graphs so that you've got new ones that you can write on and work on. So if you want, you could pause these videos every time we do a new graph, and you could copy down that graph and then start again. All right, so what we're going to do first is we're going to take a look at the graph of f of x equals the absolute value of x, which looks like this. If you want to take a moment to draw this graph yourself, pause the video and do so. But to make these videos shorter and save time and bandwidth, I'm just going to have them appear kind of magically. So what we're going to do is we're going to use this graph to figure some things out about the function. We are not going to use the equation for the function, and in fact, we're going to pretend we don't even know that this is f of x equals the absolute value of x. So let's answer some questions about this function. Let's find f of negative 1 and f of 2. So again, we're not going to use the equation. We're going to pretend we don't even know what the equation is. We're going to use the graph and see if we can figure out this information based on the graph. Now, f of negative 1 is the function value when x is negative 1. So what I'm going to do is I'm going to look at negative 1 on the x-axis, and the vertical line that goes through negative 1 on the x-axis is the line that has the equation x equals negative 1. So what we're looking for is we're looking for the y value of the part of the function that falls on this line. And we can see that that point is going to be right here. This is the point of the function that corresponds to x equals negative 1. And we can see that the y value is positive 1 because it's 1 unit above the x-axis, or if we move to the right, we can see that it corresponds to 1 on the y-axis. So by looking at this, we can say that f of negative 1 is equal to positive 1. We can do something similar to figure out f of 2. If we want to figure out f of 2, we look at x equals 2, and we try to see where on the vertical line x equals 2 our graph crosses. It's almost like looking for an intercept, but we're looking on a line that's not an axis. We're looking at the line x equals 2. Now we can see that the graph goes through this line right here. This is the point on the graph that has an x-coordinate of 2. And we look at the y-coordinate, that's also 2. So f of 2 is going to equal 2. All right. Now, let's look at another question for which x values is f of x equal to 5. That is not the prettiest 5. Let me edit that up just a little bit to make it nicer. There we go. All right. So now we're asked a different sort of a question. Which x values have f of x equal to 5? Remember that f of x is just another way to write y when we're dealing with a function. So here we're looking for the points where y is equal to 5, and we want to know what x values correspond to those. So if we look at y equals 5 here on the y-axis, and we look at the horizontal line that goes through that point, these are all the points that have a y-coordinate of 5. And so we want to see where the graph intersects this line. We want to see where the graph has this height. And there are 2 points. One of them is here, and one of them is here. So what we can do is we can look at the corresponding x values that give us a function value or a y value of 5. The first one is 5. When x is 5, we can see that f of x is 5. And then the second one is going to be negative 5. When x is negative 5, we also have a function value of 5. So the x values for which f of x is 5 are x equals 5 or x equals negative 5. We can figure out this information visually just by looking at the graph without referencing the equation. This is important because there will be some situations where we have a graph of a function, but we don't have the equation that represents the function. And there are several situations where we might have a graph that doesn't have a nice equation. For example, the number of COVID cases, new COVID cases every day. When we looked at that the other day, we saw that it's not a nice function. It's not going to look like f of x equals the absolute value of x or f of x equals x squared. There's no nice equation because the numbers are changing so erratically every day. So in a situation like that, we need to be able to get this information from the graph because we don't have an equation that we can use. Now, being able to read information from graphs is important, and we will look at this more in the future, but I really want to focus on 2 particular concepts today, domain and range. Let's talk about the definitions and see how we can figure out what the domain and range are graphically. The domain of a function is the set of all possible input values, or x values, and the range of a function is the set of all possible output values, or y values. We're going to start by looking at the domain. And we're going to do this all in blue just so that we're color coding things and you can see what's going on. So the domain is the set of all possible input values or x values. So for example, 5 is part of the domain because 5 is an input value that gives us a point on our function. And 2 is in the domain because 2 also is a value that gives us a point on our function. And if we look at the part of the graph that lies in between these 2 points, and we look at the corresponding x values, those fill in all the points between 2 and 5. So what we do is we're kind of projecting all of these points down onto the x-axis. We're looking at every point on the graph and saying, where does that hit on the x-axis? And we're asking what parts of the x-axis end up getting hit by the graph. So what we're going to do is we're going to keep doing this. If we go to the left, we go all the way to 0. And then when we go on the other side, we're getting the negatives. And if we look at our graph, it keeps going to the left. And it's never going to stop going to the left. So if we continued to project, we would still be projecting from above. And what's going to happen is we're going to have the entire x-axis all the way to the left. That's going to be a part of the domain. And the same thing is going to happen on the right if we continue kind of projecting these points down onto the x-axis. It's going to go to the right. And the entire x-axis is going to be part of the domain. So the domain is going to basically be all real numbers. Now, we are going to use a special notation when we're talking about domain and range. This is called set notation or set builder notation. And I'm going to give you the notation first, and then we're going to talk about it. So here, the domain, we're going to have a squiggly brace, and then the letter X, because the domain corresponds with X, and then a vertical bar, and then we're going to write X is a real number. All right, the way that we read this, we're going to read that squiggly brace as the set of numbers. So that squiggly brace is the set of numbers, and then X. And in that vertical bar, we're going to read such that. So this vertical bar means such that X is a real number. And we don't actually say anything for this closed brace that just ends the thing. So we read this as the set of numbers X such that X is a real number. So the domain isn't a single number. It's going to be a whole set of numbers. It's going to be a lot of them, infinitely many. And so we use this notation to talk about how we describe that set. And so this is the set of numbers X, and we're using X here because X represents the numbers in the input values, and that's what the domain is. This vertical bar, we say such that, because this vertical bar says everything to the right of it will be the restriction, the thing that tells us which X values are a part of the domain. And in this case, because all real numbers are a part of the domain, the only restriction is that X is a real number. This probably looks confusing right now. What we're going to do is we're going to look at the range also so that we get a little bit comfortable with that. And we're going to do several examples in several videos so that you can get comfortable with finding the domain and range and all of this projection stuff and the notation. So if it seems a little bit intimidating right now, I don't want you to worry. We're going to get lots of practice and you will get more comfortable with it pretty soon. Let's move on and let's take a look at the range, which we're going to do in red, just because blue and red are two of the colors that I have here that are very strikingly different, and they're dark enough that they're easy to read. So the range is the set of all possible output values. So what we're going to do is we're going to look at a point, for example, this point on the graph, and we're going to say what y value corresponds to it. And in this case, that y value is 2, so we know that 2 is part of the domain. If we look at this point up here, and we ask what's its y value, we can see that 5 is the y value. So 5 is part of the range. And if we look at these points in between, we can see that they correspond to y values ranging between 2 and 5. So we know that all of those numbers are part of the range. Let's continue. If we continue going up to the right here, we can see that if we project these onto the y-axis, we end up with larger and larger y values. And because the graph continues going up forever, we're going to have all of the y-axis above this colored in. Now let's look down here at the lower values. If we project these onto the y-axis, we can continue our range all the way down to 0. Now if we look at points on the left-hand side of this graph and we project them onto the y-axis, we're still going to end up getting all these positive values. And so all of this is going to correspond to these points with positive y values along with 0, but there are no points on the graph down below that will project to the negative values of y. So here we get all the positive values of y, those are all in the range, and 0 is in the range because we do have a point that has a y value of 0, but nothing that's less than 0 is in the range. So what we're going to say here is the range is the set of numbers y such that y is greater than or equal to 0. The range doesn't include any negative numbers, and the way that we can express that mathematically is we can say that y has to be greater than or equal to 0. Now, we're going to be doing some drawings like these for some of the other graphs, but it sometimes is difficult to do this if the graphs are pretty complicated. So we eventually want to get to the point where we can just look with our eyes without drawing all of this shading in to see which x values are covered by the graph and which y values are covered by the graph. In the next video, we're going to do a couple more examples, and then we're going to have another video with even more examples so we can get comfortable with this process and also identify the domains and ranges of those foundational functions that we looked at yesterday, the important ones that we're going to see over and over again.